Continuing with this series of videos about comparison between groups, let's talk about MANOVA. MANOVA is very much like an ANOVA. The big difference is that it has several different dependent variables, and these dependent variables are all score variables, and the independent variable is a categorical variable. So as you can see here, we have 4 variables. In our example, we have the subject number, we have a university, anxiety and depression. Anxiety and depression are our dependent variables, and as you can see here on the data view, they are score variables. These scores in the scale range from 0 to 100, and in this example we want to check the anxiety and depression levels that students from 3 different universities, you can see here in our independent variables, university A, B, and C, have when coming during a final test at the university. As with any test, as you should already know, there are some assumptions and some restrictions. Some assumptions that should be met, that your data should be made in order to run the test, and some restrictions, so you know whether you can use or you cannot use the test. So the independent variable must be categorical with at least 2 groups. As you could see in our independent variable university, we have 3. We have university A, university B, and university C. The dependent variable data must be interval or ratio, and as you could see here, our anxiety and depression variables are score variables. Let's go to the data view, and you see the scores here. In this scale, for this fictional example, this scale ranges from 0 to 100. Let's go back to the variable view. Now let's keep in mind, in this fictional research, the researcher wants to check the anxiety and depression scores of students when they come to a final exam. Going back to the assumptions and restrictions, as usual, the data should be normally distributed. Again, you should not have outliers, and there should be a reasonable correlation between the dependent variables. What do I mean by reasonable correlation? In short, there is no clear answer to this, but the idea is that if you have a correlation that approaches 1, then you essentially have only 1 variable and not multiple variables. So the correlation should not be too strong. Ideally, the relationship between these variables should be no more than moderate. This is, if you have a negative correlation, shouldn't exceed -0.4, and if you have positively correlated variables, should range between 0.3 and 0.9. Additionally, you should have homogeneity of variance between groups. This is measured via the Levine test. I'm going to show this, of course, later, but is already covered in the ANOVA video. Additionally, correlation between dependent variables should be equal between the groups. And finally, we should avoid having too many dependent variables. So, despite we have already some videos about the assumptions, I'm going to show once again here in this video how to check for them. So, first, let's check if our data is normally distributed and has no outliers. So to do this, you just come to Analyze, Descriptive Statistics, and click on Explore. Let's move Anxiety and Depression to the Dependent List box, and move University to the Factor List box. We don't want Statistics, so here click Plots. So you can see here the Statistic button is no longer available. Click on Plots. We want the box plots dependent factors together. Deselect stem and leaf, and select normality plots with tests. Click on Continue. We leave everything as default. Click on Paste. So the syntax window opens, select and click on run. So let's test the normal distribution of our data. We are going to do this by checking at the Shapiro-Wilk part of this table. Now, why we are taking a look at the Shapiro-Wilk test and not the Kolmogorov-Smirnov test? So briefly stated, the Shapiro-Wilk test is a specific test for normality, whereas the method used by the Kolmogorov-Smirnov test is more general but less powerful, meaning it correctly rejects the null hypothesis of normality less often. So both statistics takes normality as the null and establishes a test statistic based on the sample, but how they do it is so different from one another in ways that make them more or less sensitive to future of normal distributions. If the assumption of normality has been violated, the significance value will be less than 0.05. As you can see here, our test of normality, the Shapiro-Wilk test, shows us a significance of 0.1, 0.8, 0.8, 0.9, 0.2, and 0.5. So the assumption of normality has not been violated. So now let's take a look at the plots, and you can see here that we have a positive correlation among this line. These plots, as any plots on SPSS, are a graphical aid for you to see the information that has been presented in these tables. We can see here again, these dots are pretty much along this line, and we have a positive correlation. And you can see here again these plots. Now for University B, you see there is a line there, and the dots go pretty much along them in a positive correlation. University C, and so on and so forth. Now let's take a look at this box plot, and here we are checking the assumption of no outliers. If we'll have some outlier in our data, we will see a circle with a number. So the number will be the number of the case. So if, for example, we'll have this in this 40 case, a number of say 622 will be way different from the rest of the values here. That will be an extreme outlier, and you will have an asterisk in this box plot. But since we don't have any of those circles or asterisks, we don't have any outliers in our data. How to proceed if you found outliers on your data set? That has been already discussed in the checking for outliers video, so I strongly recommend that you take a look at it if you have any doubts. So we have to check as well for multicollinearity, and to do that we have to check the correlation among our dependent variables. In order to do it, you just have to come to Analyze, Correlate, and select Bivariate. Now we want to take, of course, our dependent variables, anxiety and depression, to the variable box, and we'll keep the Pearson correlation coefficient selected and the test significance into tailed. Now, of course, you have here a correlation of 1 and 1 because anxiety with anxiety correlates perfectly, so we can disregard these two boxes and these as well. As you can see here, these are exactly the same. So we can take a look only at this, and as you can see, we have a correlation of 0.16. This is a weak correlation, and as I said before, it's better if your variables, when they are positively correlated, are in a range between 0.3 and 0.9. However, in order to continue with this example, we will go on with it. Once again, consult your research team or your supervisor in order to get an advice how to proceed if you have a value like this and the significance is also bigger than 0.5. So let's now test the assumption of linearity, and to do it you first have to split the file. How to do it? You just come to Data, Split File, click on Organize Output by Groups and Group Space on University. Click on OK, and you can see here in the output window that the action has been performed. Now go to Graphs, Chart Builder, click on OK, select Scatter Dot, drag and drop this one here, and select Anxiety, drag and drop on the scatter matrix, and take depression to the same box. Click on OK, and we have this plot based on university A, B, and C. What we are looking here is, as with the normality test, some line in order to see how the data is distributed across that line. And we can see here some patterns emerge here and here and here. So with this we can say that the assumption of linearity has not been violated. Now, before we can proceed with the ANOVA, there is one more step we have to perform, and is to test for multivariate outliers. In the previous step we checked for univariate outliers, and now in order to check for the multivariate ones we have to do some regression analysis. And these multivariate outliers are calculated in the regression through a measure that is called the Mahalanobis distance. And I'm going to show you how to do it and how to read the information from it. So click on Analyze, go to Regression and select Linear. Take your anxiety and depression scores to the independent variables, and here in the dependent select the subject. Now let's go to Save, and we have a lot of options here. We want the Mahalanobis distance, so now we can click on Continue. So we need to go back to our variable view, and as you can see a new variable was created. This is the Mahalanobis distance values. Let's go to the data view, and you can see here these values. So right click on the name of this new variable and select Sort Descending. Now we have these values that range from 7.8 to 0.01. What's the point here? When you have two variables, there is some values that tells you if you have multivariate outliers, and here's the table. As you can see, the critical value for two dependent variables is 13.82, and our maximum value here is 7.8. So we have not violated this assumption of multivariate outliers. We don't have multivariate outliers. This means that we can continue and proceed with the MANOVA. But before we can run the MANOVA procedure, we have, as you remember, we split a file. We need to unsplit it. So this is really easy. Go to Data, Split File, and click on Analyze All Cases. Do not create groups. Click on OK. And as you can see here, split file off command has been run. We can now proceed with our analysis. So in order for you to run a MANOVA, you have to come to Analyze, General Linear Model, and click Multivariate. So we have anxiety and depression, move to the dependent variables, and the fixed factor is university. Now click on Post Hoc move university to the post-hoc test form, and in the equal variances assumed part select Tukey, and in the equal variances not assumed select games Howl. Why we are selecting two different post-hoc tests? Because we at this moment have no idea if the equal variances are assumed or not, so we will need to read information from both, check the Levine test, and see if there is homogeneity of variance in our data or not. So now click on continue. Something else, in the ANOVA video I made a longer explanation about the LSD, the Tukey, and the Schiefe test for equals variance assume, in case you want to know a little bit more about this, when to use it, why to use it, and so on and so forth. So we are back here in the multivariate main window. Click on options, move university to displacements for box, and check descriptive statistics, estimators of effect size, and homogeneity tests. With this we can see the Levine test scores. Click on continue, click on paste, go to the syntax window as usual, select and click on run. So let's check for the homogeneity of variances. Again, this is measured by the Levine test, and we should have a significance value smaller than 0.05. So as you can see here, our values are bigger than that. For anxiety we have 0.1, and for depression we have 0.25. There are some adjustments that we could undertake to address this violation of homogeneity in both the anxiety and depression scores across the university groups. However, they are way too complex to perform manually, and unfortunately they are not available in SPSS when you are running a MANOVA. Finally, this homogeneity of variance outcome, this result, will also affect how we interpret post-hoc tests. So that being said, let's keep checking the results of our MANOVA. So now let's go up and check this box test of equality of covariance matrices. We are interested in this value, the significance. Since it is bigger than 0.001, you can see here we have 0.002, we can be fairly happy. Now, this box of the descriptive statistics suggests that students from University A suffer more anxiety than students from University B and C, and also that they suffer more depression than the other two universities. Now let's move down here and take a look at the multivariate tests. We can ignore this intercept box. We want to see the information from the university box. So you can see here we have 4 different values: Pillai's trace, Wilkes lambda, Hotelin's trace, and Hoy's largest root. We are going to select the Wilkes lambda because we have 3 universities. I'm not going to explain right now what is the difference between these 4, but in this case we can just focus on this one. So we are interested in the significance value as well, and as you can see here we have a value smaller than 0.05. So this means that we have a significance value. So this means that there is a significant difference between the 3 universities in the scores they get as a whole, both anxiety and depression scores. Now we should switch to the tests of between subject effects, so we can check which dependent variables appears to have more effect on this significant MANOVA result. So for example, here you have to check this row, university, anxiety score, and check the p-value here, the significance. And when you are reporting this in your paper or the report you're making for the university, you also have to read the error row in order to include this information there. And the same for depression. We have a significant value here, and again you'll have to use this information from the raw university and the error on depression as well when you are reporting this. I will include some links on how to write this down. I'm not going to show it to you on this video, so make sure to visit the blog in order to know how to write it if you don't know how to write it. And here finally we have in the post hoc test, as you remember, we selected both the Tukey and the games howl because at the moment we didn't know if we had the assumption of homogeneity of variance met or not. Since we met that assumption, we can disregard the games howl information here and just focus on the Tukey HSD information in both the anxiety and depression scores. Now this video is already too long. If you want to know how to interpret the values from the Tukey HSD, please go to the ANOVA video where there is in-depth explanation about how to read and interpret this information. So with that being said, we can conclude this video. I want to thank you for your time, and I'll see you next time.